With any set of data inside a Geographic Information System or GIS, you're not confined to just the 2D world. The 3D world is really quite powerful in terms of how to visualize and analyze and make sense of your data, all the patterns and the relationships that might exist in your data. Let's demonstrate how easy it is to bring your data into the 3D environment. Now, don't just think of elevation data, right? Data about the terrain of the Earth as being possible to model inside the 3D world. You can model anything in 3D. Why do it? Well, you might be able to, in 3D, see some patterns, relationships, and trends in your data that you couldn't see in the 2D world. For example, population, or pH of streams, or the distribution of invasive species in a certain plot of ground. All of these things and more can be brought into the 3D environment. Let's demonstrate how to do that. There are some powerful things you can do with 2D mapping. Sometimes, though, you want to visualize things and explore data in a 3D environment. It doesn't have to be elevation data, as I mentioned earlier. It can be population, it could be water quality, it could be anything. Let's go ahead and illustrate what I mean. I'm going to go ahead and fire up the ArcScene application inside ArcGIS Desktop. Okay, there's my 3D ArcScene. Let's go ahead and add data. How about states, population? Okay, there it is. Not too exciting yet though, right? Because there's nothing really 3D about it. First, let's go ahead and symbolize based on some attribute. How about 2010 population? Okay. Alright, I've got some population data there, but it's still flat. So, go ahead and double click on the layer, and let's do an extrusion. Extrude features and layer. Extrusion turns points into vertical lines, lines into walls, and what we have is polygons into blocks. So my extrusion, I'm going to put 2010 by... Okay, let's do the same kind of thing with cities now. I've got cities, and I'm going to extrude those based on the population. In this case, I've got some 2,000 populations. Okay, so there I've got some major cities. Now, the vertical bar for these cities is the size of the cities. So there's definitely a relationship, right? We can see some of these low population states with few large cities, but then we've got other places like California, Texas, but also look at Arizona with some large cities. Interesting. Now remember, let's look at what we're examining. The symbology, the color is the change, the rate of change, with dark being high change, and yellow even some places, some states that decreased in population. The extrusion is the raw population, so the height is basically the raw population. So the height is the raw population. The color means how fast it's growing. And then we've got the states in this data set. It could be counties, it could be census tracts, block groups, any kind of unit. Could be whole countries around the world. So don't be limited to thinking you've got to look at states of the United States. The last thing we added was cities. And so these cities, we're just mapping them based on their raw population. And to check that, go ahead and go back in here where raw population, and we are classifying all of those as this single symbol. Great! I've got some cities here with population from the year 2000 census. I've got them mapped on the raw population. So I can see some patterns here, definitely. I see that the middle part of the country, for example, is relatively devoid of large cities. There's another thing I can do though, just like I can do in the 2D world. I can go ahead and map these symbols for cities based on some sort of quantity. So let's say we take the school-aged population, age 5 to 17, and divide that by the population in 2000. So let's take a look. Let's make the symbols a bit larger. Okay, so blue is going to be higher percentage of school-age kids in terms of the general population, and this peach and yellow color are going to be cities with lower. So let's say I'm designing a program where I need to address cities with a high percentage of school-age population. So I'm going to say OK there. Aha, now I can see that not all cities are created equal. There are certain cities that are very large in size, New York City, Chicago, for example. Let's go ahead and click on the Identify button. Okay, so there's New York City, and there is Chicago. Yep. And over here out west I've got Los Angeles. So those large cities have about a medium sort of average in terms of the school-age population, but not all cities are created equal. So let's go ahead and examine. Look at this one right here. Detroit has a higher percentage of school-age kids than other large cities. Interesting. And same with this city down here on the border. And looks like Phoenix has a higher percentage than others. And so does San Antonio and Memphis. So what does this mean? Well, if we're designing a program, interestingly, there's a lot of cities over here in California with a higher percentage of school-age population as well. So, okay, well, can we look at that in relationship to states? Absolutely. Let's go ahead and pull up our states data again. Okay, what do I have here? The raw values that I'm mapping in terms of how high they are, how extruded they are basically the 2010 population. And I divided it by 50 so it wouldn't be extruding out to Mars. So I'd actually be able to see it on my display. So the extruded values are the total population. The colors, the darker the color means the faster the growth. So how high they are is the raw population. The colors mean they're faster growing. So now I can see that in some states I've got some faster growing states and a variety of different kinds of cities in those states in terms of the school age population, and in other states I have a slower growth and a lower school aged population, and in other states the pattern totally breaks down. For example, over here where I've got a higher school aged population, but yet the state is not growing as fast, and indeed it's actually decreasing according to this data set. If we go ahead and go right over here and make that a yellow color, that state is decreasing in population. This one right here, Michigan. So interesting. We can visualize and make connections between different variables inside the 3D environment. So 3D, quite a powerful technique and easy to do. And again, think of other data that you could map and analyze in the 3D environment. Thanks.